is we're going to talk a little bit about the converse theorems. All right, before I do that, I just want to mention before we carry on, sorry, I seem to have forgotten to put that over here, that the two theorems covering cyclic quads are as follows. Okay, so in other words, for a quad to be called cyclic, it has to have 4 points on the circle, right? So in our previous diagram where we were having a look at, let's just, where was it? Up here. At ATCB, all right, the reason that ATCB is cyclic, and they don't need to tell you it's cyclic, is because A and T and B are on the circle. All right, so what's important for us when it comes to cyclic quads is that, number one, let's just go down here. So I'm just going to write this in quickly. So when it comes to cyclic quads, the two things that you always need to remember is, number one, the opposite angles of cyclic quads, of a cyclic quad, are supplementary. So that means they add up to 180 degrees. And the second thing that we need to remember is that the exterior angle of a cyclic quad is equal to the opposite interior angle. Yes, Timber, go for it.
Sorry, ma'am, I was asking, maybe it's just me, but I can't see your screen share.
Oh, can't you? I am sharing. Okay, that's fine. Can anybody else, is anybody else struggling to see my screen? I am screen sharing. At least I thought I was.
No, ma'am.
You can't see anything?
No, I can't see it. It's
fine.
Oh,
you can see it. Oh, okay. All right.
Maybe September, do you mind maybe leaving and then coming straight back in? I think that might help a bit.
Okay, I'll try.
Sure.
Sorry, September. Okay, so we spoke about this a little bit in our previous lesson, right? So the opposite angles of a cyclic quad are supplementary, they add up to 180 degrees, and the exterior angle of a cyclic quad is equal to the opposite interior angle. So as I was saying before, right, if you've got a cyclic quad, and I'm just drawing one here very, very quickly for us, right? In order for us to say that there's an exterior angle, it has to be one of the four sides that has been extended. Okay, so in other words, if I extend that over there, then this exterior angle over here will be equal to that angle over there. All right, but if it's just a line that comes off the cyclic quad and not an extension of the side, then this number 2 exterior angle of cyclic quad equals opposite interior angle will not apply. All right, now the things that we often find a little bit more difficult in geometry are when we have to prove converses. All right, so number 1, number 2, and number 3 are how we prove that quads are cyclic, and they will always ask you to do this. All right, so if you go and have a look at any matric exam from the time that we started doing geometry again, you will always be asked to prove that a quad is cyclic as one of the questions. Okay, so this is definitely something that's going to come up. So
can you repeat which numbers are they going to ask?
Okay, so they will always ask either 1 or 2 or 3 will always be asked. Okay, so in other words, they will always ask you to prove that a quad is cyclic. But there are 3 different ways that you can do that, Noxie. Okay, so if we can show by other means that angle A plus angle C is 180 degrees, then it means that ABCD is cyclic. If A plus C equals 180 and ABCD is cyclic, we will use the reason converse opposite angles of a cyclic quad, okay? If in a different scenario, a different question, we were able to prove, or it was given to us, that angle A, so this angle over here, equals angle DCE. Oopsie, that's not right. Sorry, there's a sorry, ECD, that's it. So it would be this angle over here. All right, sorry, there was a mistake with that. That should be, it's just a typo. Okay, so that should be BCE. then the reason that ABCD is cyclic is because of converse exterior angle of cyclic quad. Okay, so if A is equal to angle BCE here on the outside, can you see how DC has been extended to E to create that angle on the outside? Then we could prove that ABCD is cyclic using converse exterior angle of cyclic quad. And then the last way that we can prove that a quad is cyclic is if we are able to prove. Now, when we say here that then ABCD is a cyclic quad or ABCD are concyclic, what we would need to prove for converse angles in the same segment is either we would need to prove that C and D are equal to one another, or we would need to prove that B and C are equal to one another. So if B equals C, or if A equaled D, then we could prove that ABCD is a cyclic quad because of converse angles in the same segment. Right, so that is something that will definitely always be asked. Some things that are sort of slightly less common is like number 4 and number 5. So in number 4, they're asking us to prove that BT is a tangent to a circle. All right, so in other words, if we know that OTB is 90 degrees, then that means that BT has to be a tangent to the circle. So that would be converse radius tangent theorem. All right, so we would have to be told, or we would have to be able to calculate that OTB was 91st and then be asked to prove that BT was a tangent. Something else that they can ask you is to show that BC is the diameter of a circle. So I don't know if you recall this from last year as well. So if they said to you that you needed to prove that BC was a diameter, then you would need to show that angle BAC, so in other words, this angle over here, you would have to show that it was 90. Then you could conclude that BC is a diameter, and we would say converse angle in a semicircle.
Yeah.
And go for it.
Ma'am, it's okay.
Is it okay? Okay, all right. Sorry, I just didn't know if you were being, if somebody was asking a question. And then another converse that also proves that a line is a tangent to a circle is converse tan chord theorem. Okay, so I'm going to highlight this in blue as well. So if BTA equals C, then it means that TA is going to be a tangent to the circle. Oh, sorry, AT will be a tangent to the circle, and that is converse tan chord theorem. All right, so if we can work out that this angle over here equals that one over there, then we can deduce that AT is a tangent to this circle. Right, so of course, Noxie, go for it.
Can you please just give me a synonym for converse? What does it mean?
A converse is an exact opposite, Noxie. Okay, so in other words, let me explain to you. Let's use this opposite angles of a cyclic quad. So Noxie, if a quad is cyclic and it has 4 points on the circle, then the opposite angles will add up to 180 degrees. Okay? That's going forwards. The converse goes backwards. The converse says if we have a quad and the opposite angles add up to 180 degrees, then that quad is cyclic. Converse opposite angles of a cyclic quad. Do you see the difference between the two? So the one goes this way and the other one is the exact reverse of that. Okay, so what we are given and what we are trying to prove are opposites.
Oh, okay.
Does that make a little bit more sense?
Yes, ma'am. Thank you.
All right, so when you are proving that a quad is cyclic, what are we actually proving is possible? Do you know? Does anybody know what that actually means? So when you prove that a quad is cyclic matric, what you are doing is that you're proving it's possible to draw a circle through the 4 points. That's really what it means. Okay, so proving a quad is cyclic proves that it's possible to draw a circle through all 4 points, and that those 4 points will lie on the circumference. That's what you're doing when you're proving a quad is cyclic. Okay, so let me go and show you an example of how we would do this. But unfortunately, it's kind of hidden in another question. That is a very difficult one. Let me see, prove that. Let's just see if this one here. No, okay, let's do this. This is a nice one. This is actually a very nice one to get started. Okay, so we have been given that KLMN is a cyclic quad, right? And the other thing that they've told us is that KM and LN are joined together. Okay, so they've joined those, they've joined the lines. Okay, so T is a point over here and S is that point over there, such that KN is parallel to TS. All right, so very, very important, guys. The minute they tell us that lines are parallel, we have to start thinking alternate, corresponding, or maybe even co-interior. Okay, if KLMN is cyclic, then what that means for us is that angle K1 plus K2 plus M1 plus M2 adds up to 180. All right, also this angle over here at L plus this angle over here at N, they will also add up to 180. The first thing that you should do...
Can I just interrupt quickly, ma'am?
Yeah, of course, go for it.
Are you writing anything on the screen?
I'm going to be.
Oh, okay. Sorry.
I'm going to be. Yeah, I haven't done so yet.
Oh, okay.
Yeah.
I thought maybe something was wrong with your pen, but no. All right.
No. Can you see that? I'm writing in green.
Yes, wonderful. Thank you.
Okay. All right. So, excuse me. The first thing. Oh, excuse me. Sorry, guys. The first thing that you want to do when they ask you to prove that a quad is cyclic, get your highlighter matrix and go and highlight the quad so that it stands out to you. Okay, so that's what I'm doing now. I'm taking my highlighter and I'm just highlighting the 4 straight sides of would-be LTSM cyclic quad, right? Now, I'm having a look at what is inside LTSM, all right? In order for me to prove converse angles in the same segment, there needs to be a bow tie inside. There's no bow tie inside. Yes.
Can I please ask, how can LTSM can be a cyclic quad if angle T is not touching the circumference?
Okay, so Amanda, what you are doing when you are proving that it's cyclic, you're proving that it's possible to draw a circle through those 4 points, not that there's necessarily one there. So when I prove that LTSM is cyclic, I'm proving it's possible for me to draw a circle through T, L, M, and S.
Oh, okay, ma'am. Thanks.
That's what we're proving. Okay, so we're just proving that it's possible, not that it necessarily is there, but that it is possible for us to do so. Okay, so when a quad has all 4 points on the circle, it's automatically cyclic. When a quad does not have all 4 points on a circle, but you can prove that it's possible to draw a circle through it, then it can also be a cyclic quad. Okay, and then the only way you would be able to prove that that's possible is using those 3 converses. Right.
Okay, thank you.
Right. So there is also a way of being able to narrow down the information. If just go back up here and go and have a look. All right. If we want to prove that a quad is cyclic using converse angles in the same segment, let's just join those together. There's got to be a bow tie inside matrix. Okay, if there's no bow tie inside, then chances are we're not going to be able to use converse angles in the same segment. Right? If we want to prove that it's a cyclic quad because of converse opposite angles are supplementary, then we need to know something about these angles. They've got to give us the angles or tell us what size they are, right? If we have a look at the diagram that we've been given, we don't know any sizes. We don't know how big anything is. There is also no bow tie inside TLMS. So that means that the only remaining way that we can prove that it's a cyclic quad has to be the one. And that's by proving that the exterior angle is equal to the opposite interior angle. So in other words, if we can prove, so let's extend it in a different color. I can extend side TL. Can you see that? I can extend side TL, and T1 would be the exterior angle of the cyclic quad. So if I can prove that T1 equals M1, then I've proved that this quad is cyclic. My other option here is to prove, so this side is also extended over there, is to prove that S1 is equal to this angle over here at L. Right, that would be the only other way that we could do this. We could prove that it was cyclic. I think it's probably more likely that it's T1 is equal to M1. And that's because we've got those parallel lines there. Okay, so once we've looked at it, we first have to say to ourselves, what does this mean and what can we use? So proving a quad is cyclic means proving that it's possible to draw a circle through the 4 points. How do we do that? One of our 3 converses. If there's a bow tie inside, then we can use converse angles in the same segment. If we know something about the angles and we know something about them adding up to 180 degrees, then maybe we can use converse angles in the same segment. Otherwise, the only other way to be able to prove that a quad is cyclic is to prove that the exterior angle equals the opposite interior angle. So it looks very likely in this diagram as though that's the way we need to go. So once we've identified what it means and how we're going to do it, now we have to go and look at the angles involved. We know that proving LTSM is cyclic means proving that T1 equals M1, right? That's what it means, right? So in other words, i.e., proving that LTSM is a cyclic quad means proving that T1 equals M1. So now that we have identified the angles that need to be proved, let's go and have a look what T1 and M1 are equal to. All right, so now out comes all the other geometry that we're supposed to know, alternate angles, any angles that could possibly be equal, okay, including all of our grade 11 stuff. All right, so let's go and have a look here. We've got this parallel line over here, and we can see that angle N1 would be equal to angle T1. All right, now is angle M1 equal to angle N1?
Yes.
Yes, it is. Okay, what's the reason?
Angles in the same segment.
Exactly. Okay, so there you can see, all right, N1 is the link between T1 and M1. All right, and it's often like that in geometry. You've got to see how these 2 angles are attached to one another. So pick one of them, go and see what else it's equal to, and then ask yourself, well, is the other angle also equal to that? Is there some kind of connection here? All right, so this is what we would write matrix. We would state that T1 equals N1, alternate angles. That's because Kn is parallel to Ts. Then we would state that M1 equals N1. And the reason for that, as you told me, is they are angles in, whoopsie, not is, in the same segment. Okay, so if two things are equal to the same thing, then they must be equal to one another. So now, very important. Therefore, T1 equals M1. This is what proves it. We have to make that statement. Therefore, LTSM is cyclic. And our reason is going to be converse. Exterior angle of cyclic. Oopsie, it's not cyclid. Sorry. My brain seems to have gone on holiday. Cyclic, which is no good. Cyclic quad. Go for it, Karabo.
Karabo, it seems your mic isn't actually connected. So you might need to look for a button, 3 buttons where you can connect your microphone so you can speak to ma'am. There we go, we're connecting to audio. Okay, and don't forget to unmute and then ask your question. Oh no, have we lost her?
I don't know.
Oh, she's still here. She's just put her hand down.
Karabo, did you want to ask did you want to ask something? All right. Well, we'll see if she wants to ask again. That's fine. That's absolutely not a problem. So something like this matrix is going to be worth probably about 4 marks. Okay. So here, there would be a statement reason mark on the line T1 equals N1 and the reason. So this would be a statement reason. So if you left off those parallel lines, they would nail you for that and they wouldn't give you the mark. Okay, so remember, if you leave off the parallel lines, they will penalize you. Then I imagine M1 equals N1 would also be 1 mark, statement reason. This is critical because this is what proves the quad is cyclic. So this statement is necessary, and then your reason over here would be your last mark. So yes, I would say as far as this question is concerned, that would be worth about 4 at the most. Okay, let's go and have a look. How does that feel? How are you feeling right now? Thumbs up, thumbs down? Is it good? Is it making sense? I want us to go and look at another one. Anyway, you can pop something in the chat for Nabuhle. Thank you, Nabuhle. Thank you, Siatemba. Casey. Thanks, Casey. Rele Bochile, thank you. Good, Okuhle. Even if it's not making sense, you don't just have to say that it is if it isn't. All right. Okay, so at least were you sure? Cool, Tato. Thanks, Amanda. Okay, Noxie, I'm glad.
I think, Lee, for me, this is going to take a bit of practice because I have to remember all the converse theorems and then remember how to apply them.
Absolutely.
I think I'm going to have to sit and engage with the maths a lot more. So I'm going to get my practice on after this lesson, make sure that I'm doing it 100% correct.
Absolutely. You know, it is going to be a little bit more difficult. So what I think we should do here is it is practice. It's like with anything, you know, everything is difficult before it's easy. And the more you practice, the easier it becomes. Let's have a look at this, but I don't want to do everything here because I want to go and have a look at one of the sort of more difficult questions that I had set aside for tonight. So let's just do part A. Because we're talking about these converse theorems and proving that quads are cyclic. And then we can go and have a look at another question, which is actually what I had for this evening. All right, so if we look in this diagram over here, is it big enough, everybody? Can you see? You just maybe make it a little bit bigger. Hopefully you can see that okay. All right, so in the diagram below, it tells us that EC is the diameter of the circle. So straight away, if a line is a diameter, what does that mean for us, matrix? Which angle is 90?
D3.
Lovely. Okay, so that means that D3 has to be equal to 90. I'm just popping that on the side. Okay, because of angle in a semicircle. EC is produced to B. So all that means is that EB has been extended until it gets to B. BD is a tangent at D. So straight away, I see the word tangent. So now when I see the word tangent, I'm saying to myself, tan chord theorem, maybe radius perpendicular to tangent. Do I have tangents from the same point in this question? No, I don't. Okay, but I must have tan chord theorem if they've told me that it is a tangent. The other thing, ED is produced to A, so that means that they've extended E to D to A, and AB is perpendicular to BE. All right, so this AB perpendicular to BE is this bit over there. Okay, that right angle over there. Right. We also know from our conversation that angle D3 has to be 90 as well. Okay, so proving that ABCD is a cyclic quad, the first thing that we're going to do is we're going to go and get our highlighters matrix. And we're going to go and highlight ABCD. Okay, so that's this one over here. Come highlighter, there we go. AB, let's just move this up a little bit. Why is this not working? Come now. There we go. Okay, highlight it for yourselves so that it pops out. Can somebody...
I believe Sando has a question.
Yes, absolutely. Ntando, go for it. Oh, I didn't mute you. If I did, I apologize, but I wasn't trying to mute you.
It was most likely me, ma'am.
Okay, all right. Ntando, go for it.
My finger on the mute button. I'm sorry.
Okay, no, that's fine. Ntando, go for it.
Ntando, is your mic working? It doesn't seem like we can hear you at all. Okay, that's curious.
Ntando, if you want to ask.
Okay, I see. Yeah, her mic might not be working. Do you mind maybe exiting and coming back in, and then we'll attend to your question just after this? Okay, so you just leave the meet and join straight back in, and then maybe your mic will be working there.
Okay, so this is actually very similar to the previous question, which is a little bit disappointing. But anyway, D3 is equal to 90, angle in a semicircle. And we can see that angle B, so B1 plus B2 or CBA, whatever we want to call it, is also equal to 90. We have been given that. All right, so can you see here that line AD is extended past this right angle? So because one of the sides of the quad that we're trying to prove is cyclic has been extended, we now have an exterior angle that is equal to the opposite interior angle, and that proves that this quad is cyclic. Okay, so again, we've proved these two angles are equal. Now we can conclude that D3, this is what proves it, so this is important, D3 equals CBA, let's call it that. Therefore, ABCD is cyclic. And our reason is converse exterior angle of cyclic quad. Okay, in this case as well. All right, is that okay, everybody? Does that make sense?
Yes, ma'am.
Cool. So let's go and have a look at a slightly more difficult question. All right, so we're going to go here. Okay, this is the one that I would like to start with. Right, so this comes out of a matric paper, in fact, in 2018, and that's where I've copied and pasted it from, right? So this is the sort of thing that you can expect, all right? So first of all, it tells us in the diagram, there is a smaller circle, ABTS, and a bigger circle, BDRT. BT is a common chord. So in other words, BT is in both circles. Straight lines STD and ATR are drawn. Chords AS and DR are produced to meet in C. So it just means that they are extended to meet at C, which is a point outside the two circles. Right, so this is point C right down at the bottom here. Then they've also drawn BS and BD. And the other thing that they've told us is that A is X and R1 is equal to Y, and they've labeled them. There's not really an awful lot of information here. It's not like we've seen the word tangent. We've seen a common chord. Have they used the word tangent anywhere? BT is a common chord. No, so they haven't told us that any of these lines are tangents. All right, so now let's go and have a look at the diagram. And the first thing that they want us to do is work out another angle that's also equal to X. So what do you think, Matrix? What other angle in this diagram is also equal to X? I can make the diagram a little bit bigger for you if you'd like.
Yes, please.
There we go. Can you see that okay?
Ma'am, isn't it D1?
Beautiful, Siatemba. You saw that straight away. Lovely. Well done. Okay, so Siatemba, off to a flying start. This is 9.2.1a. So 9.2.1a. And Siatemba says that, let's just do it the other way around. Not that it matters, Siatemba. Okay, so B1 is also equal to X. Reason, Siatemba?
Angles in the same segment.
Beautiful. Nice, good, lovely, Matrix. And now let's just see what that was out of. Okay, because this is a proper exam question. It's out of 2. Okay, so if it's out of 2, Matrix, it means that there is a mark for the statement or for identifying the angle, and then there's a mark for the reason. Okay, now let's find another angle that is equal to Y. Okay, so let's go back and have a look. Let's go back and have a look at the diagram. By the way, here's Y down at the bottom. Let me just move that up a little bit. Here's Y at the bottom. I'll just kind of highlight it for you a little bit in pink. Okay, it's also out of 2 marks, perhaps not quite as obvious. Yes, Ntando, B1 is equal to X. Sorry, is it Nobuhle?
Yes, ma'am.
Okay, go for it, Nobuhle. Which angle is it equal to?
I think it's equal to B2 because of exterior angle of a cyclic quad, BDRT.
Wow, I'm super impressed. That's really good. Well done. Do the rest of you see that?
Not exactly.
Not exactly. That's fine, Aisha. That's why we're here. Okay. It's not an easy thing to see at all. Now, this is where your highlighter is your best friend in geometry. Okay. So this is what Nobuhle has spotted. Okay. She's looking at the big circle. Okay. And she is saying that if we look here, we've got line TB. Here we've got line, oh, sorry guys, I'm doing this so badly. We've got line, sorry, I'm trying to draw a straight line here and it looks terrible. We've got line TR, that's this line here. Then we've got line RD. And then we've got this line over here. Oh man. I'm really struggling to draw these lines.
I think it's good enough. I think we
All
get
right,
it.
so that does the trick. Okay, so I'm just trying to highlight, can you see, Aisha, that's a cyclic quad? Okay, because it's got 4 points on the circle. B's on the circle, T's on the circle, R's on the circle, D's on the circle. All right, so angle, so line DR has been extended to C, making Y the exterior angle of the exterior angle of the cyclic quad, so it will be equal to the opposite interior angle, which in this case is going to be angle B2. That was a fantastic spot, Nobuhle. Well done to you. You deserve a little round of applause for seeing that one, because that wasn't easy. Okay, so that was exterior angle of cyclic quad. Again, this was out of 2 marks matrix. So there would be 1 mark for identifying B2 and another mark for the reason. Yes, Talia, that's why you must use a highlighter. I mean, obviously you'll be able to draw better on your page that I can draw on the screen right now, but highlight stuff, I promise you, it really makes such a difference. Janae, you had your hand up, go for it. What do you want to ask?
Janae, remember to unmute.
Ma'am,
Yes.
I just wanted to ask, do you get your 1 mark if you write B1 is equals to X without the reason?
Yes, Janae, you will get 1 mark. Okay, so yeah, to get 2 marks there, you would have to write the reason and the statement. So this first part, the equation, this is called the statement. And then this bit over here that I'm underlining in pink, that's called the reason. Okay, perfect. All right, now another question. Prove that SCDB is a cyclic quad. Okay, so now let's go and get our highlighters. Hopefully I'm going to draw this better than I did the last one. S, where's S? There. Okay, so
Please,
starting there.
Ma'am.
Yes,
Sorry,
September.
Please shift the diagram a bit to the right, a bit to the right.
A little bit to the right, no problem.
Yes. So I can see the questions.
There you go.
Thank you.
How's that?
Yeah, that's perfect.
Okay,
Thank you.
so here they've asked us to prove that SCDB is a cyclic quad. Can you see it's out of 3 marks? Not an awful lot, is it? Okay, so they've asked us to prove that SCDB is a cyclic quad, and it's going to be out of 3 marks. So now I'm going to just go down. Sorry, this is where being online is kind of limiting. And I'm just going to highlight SCDB. Okay, there we go. That's better. Okay, so matrix, there is, terrible. Okay, there is SCDB. So now remember, we've identified the quad. Now we have to think about the 3 reasons, okay? Either we can use converse exterior angle of cyclic quad, or we can use something about the opposite angles being supplementary, but we don't really know anything about any angles here. Or we can do converse angles in the same segment. In this particular case, is there a bow tie inside that we can work with? Let's get rid of the purple lines for now. Okay, so we know from what we've already done that B1 is equal to X. We also know that angle B2 is equal to Y. Now that's interesting. Yes, Aisha.
Ma'am, so I found a bow tie, and basically it's, so if you go from S to D, like that long line from S to D, and then from point R to here, just go opposite it. I don't know if
Okay, but now, unfortunately, Aisha, you are correct when it comes to line SD. But unfortunately, the line that goes from R through to T up to A, right, the bow tie has actually got to be inside. So in other words, if your cyclic quad is, I mean, we can just make it some weird shape like this, right? It has to be diagonals. So it would have to be like that and like that. And then you've got the bow tie. So either this angle over here equals that one over there, or you could say that this angle over here equals this one over there. So it's got to be a bow tie like that. So unfortunately here, there's no bow tie, all right? So that means that we're not going to be able to use converse angles in the same segment. There's got to be something else going on. A lot of the time in geometry, when they are asking you to prove things, look at the information above and say to yourself, well, what do I already have? What do I already know that could be useful to me in this particular case? And I'm pointing that out to you because we know that B1 is X and we know that B2 is Y. So we know that this entire angle over here is X plus Y. Right? Now we need to try and think about why is it X plus Y? Is there a reason that they've told us? Is there something that we can use? Look at, sorry, I'm not phrasing that very well. Okay, so now what I want you to do, okay, is I want you to look at this. Okay, so we've identified that X plus Y is one of the angles inside the cyclic quad. Now we go back and we look and we say, well, where were X and Y originally? Okay, so Y is this angle here and X is that angle there. How are X and Y connected? Oh, look at this matrix. X and Y are two angles in the exterior of a triangle. Can you see that? Can you see the blue where I've highlighted?
Yes, ma'am.
So what this means for us is that if we add together X and Y and C, can you say B plus R? We're going to say A plus R in Tando. A plus R. So angle A, which is X, plus angle R1, which is Y, is going to be equal to 180 degrees. Okay, this is because the angles of a triangle. Yes, Tato, perfect. Lovely, well done. So what this means is that C is going to be equal to 180 minus X minus Y. What else have they given us? I'm sure it's because these two have to add up to 180 degrees. Wow, okay, that's exactly it. All right. So C is equal to, I've made C the subject of the formula, and I've said that it's equal to 180 minus X minus Y. All right. Now, if I take C, let me just get a different color. Or let me just start like this. If I look at B, B is equal to X plus Y. So what will happen when I add B and C together? So B plus C is going to leave me with 180 minus X minus Y plus X plus Y. Yes, Aisha.
Oh, I was just gonna say those are opposite angles of a cyclic.
They are.
No,
They would be opposite angles of a
cyclic
cyclic quad. Absolutely, they would be. Right, but remember, we're trying to prove that the quad is cyclic. All right, so in other words, we have to prove that angle B1 plus 2 plus angle C adds up to 180 degrees. We're trying to prove the converse. So now we can show that the sum of B and C matrix is 180. Okay, so therefore, that proves that BS, let's just write this, that BSCD is cyclic. And our reason, sorry, I'm going to move this over and up a little bit now, so it'll help you guys a bit. The reason that it is cyclic is because of converse, opposite angles of cyclic quad are supplementary. Okay, so Matrix, you've gone very quiet. Please tell me how you're feeling and if this makes sense to you. There's the diagram again. Is that a smile, Siatemba? It looks like a nice big smile. Okay, Relebogile's got a big thumbs down. That's fine, Relebogile. I think
it's just
we
a
need
lot
to
to
go.
take in.
Okay, I'm lost. Okay, Tobile.
Hey, ma'am, it's tricky. Hey.
It's very tricky, Amanda. This is a very difficult question.
Yeah, I agree with Amanda, ma'am. I feel if you're not sure what you're looking for, you wouldn't know where to start.
Absolutely. And I mean, there's lines and circles all over the place. All right. So there's a few of you that are saying that you don't understand, and it's perfectly understandable that you don't understand because this is particularly difficult. Let's go back and let's try and talk about this again in the last 10 minutes that we've got, right? So what I'll do is go back to the diagram, and everybody was okay when I said the first thing that I'm going to do is I'm going to highlight the quad that they want me to prove is cyclic so that it can stick out to me and I can see exactly what they're talking about. All right, so I've highlighted that. I'll just do this. I have highlighted that in yellow. All right. When they want you to prove that something is cyclic, and now they're asking us to do this in 9.22, what we've worked out in 9.2.1 probably has something to do with this. So whatever you've already worked out above, try and look at how that can help you answer the next question. Right? Because that's how all these questions are constructed. They are constructed so that when you discover this, you can then do that, and then you can do this, and then you can do this, and whatever the case might be. All right? So whatever you have already done is a clue as to how to do the next thing. Right? That's why I said to myself, okay, well, I know what X and Y are equal to. Right? I know that angle X is this angle over here. And I know that angle Y is that angle over there. All right, so now what I see is that X and Y together make one of the angles inside this yellow quad that I'm trying to prove is cyclic. Okay, that's a hint. That's that you're onto something here, all right? So now if this is equal to X and that's equal to Y, go back and look at X and Y. So now when we look at X and Y, we see that, hang on a second, X and Y lie inside the same triangle. Okay, we're on to something, right? There is something important here, right? We know that the opposite angles of a cyclic quad add up to 180. And we also know that the angles of a triangle add up to 180. So if I say this, let me make a statement here. If I say that X plus Y equals 180, and I also say that A plus B equals 180. What can I say about x plus y and a plus b?
Can't you say they're equal to each
They're
other?
equal to one another, aren't they? Because they both add up to the same thing. Does that make sense, Matrix?
Yes, ma'am.
So if
Yes,
things have to be equal if they add up to the same thing. All right, so now this is what we've got. All right. We have got x plus y plus c that adds up to 180 because of angles of a triangle. That means that angle C, okay, so this angle over here is going to be 180. Now I'm taking the x over to the other side. And now I'm taking the y over to the other side. So that's what C is equal to. C is 180 minus x minus y because of the angles of a triangle. So in order for BSCD to be cyclic, if I add B to C, which would be the two opposite angles, will I get 180? What happens when I add B and C together? So now I'm going to add B and C. B is x plus y. Let me do this in a different color. Okay, I've worked that out from where I started. Okay, I know that to be true. I also know what C is from angles of a triangle. C is 180 minus x minus y. So what this means here, Matrix, is that we've got terms that are going to cancel one another out. X minus x is 0. Plus y minus y is going to be 0. So what we are showing to be true is that when I add B and C together, I get 180 degrees. Because B and C sum up to 180, that proves that the quad is cyclic. Okay, so now I can conclude. Therefore, BSCD is cyclic, and that's because of converse opposite angles of a cyclic quad. So because I was able to show that the opposite angles of the quad add up to 180, it proves that the quad is cyclic. It's not given that it's cyclic, we have proved it's cyclic. So we've proved that it's possible to draw a circle through B and D and C and S.
Please go back to the reason again. I just want to quickly see it again.
Converse opposite angles of a cyclic quad.
Thank you.
Okay, no problem, Sitemi. So there's only 3 ways you can prove that a quad is cyclic. Okay, so it's either converse exterior angle of a cyclic quad, converse opposite angles of a cyclic quad are supplementary, which I suppose I can just finish writing over here. And then the other one, which we can always have a look at next time, is converse angles in the same segment. All right, so this is difficult. There is no doubt about that. Much better this time. Okay, Keith, I'm glad to hear that. Okay, so because I could prove that angle B plus angle C was 180, I've proved that the quad is cyclic. Okay, that was the idea. I can't assume that it's true. I'm trying to prove that it's true. So it's like this, Matrix. If God forbid, but if somebody said, okay, Lee, you are guilty of murder, all right? I would say, okay, but why do you say I'm guilty? No, you're guilty because you're guilty. I can't be guilty because I'm guilty. I must be guilty because there's a knife with blood on it and my fingerprints, or I must be guilty because I was in the right place at the right time to be able to do that particular crime. That's why I'm guilty. I'm not guilty because I'm guilty. Do you understand what I'm getting at? So a quad can't be cyclic because it's cyclic. It's got to be cyclic because you've proved one of those 3 conditions that we've discussed this evening have been met. And in this case is that the 2 opposite angles added up to 180. Okay, I hope that makes a little bit more sense. Pumla's, okay, Pumla's got a thumbs up. That's good, Pumla. How do the rest of you feel? Is it a little bit better?
Yes, ma'am, much better.
Okay, all right, Aisha. That's great. Thanks, Amanda. Thanks, Rela Bokile. Thanks, Nabuhle. Seliswa, good. Awesome, that's fantastic. Well, unfortunately, I mean, it's 3 minutes to go. Thanks, Lisevi. Thanks, Latabo. I'm not going to start anything else now because, oh, cool, Lungani, I'm so glad. Just tell me how you feel. Do you want to do more grade 11 circle geometry, or should I move on to the matric work? If you can just put your preference into the chat, what would you prefer to do? More grade 11 or the matric stuff? More grade 11. Bearing in mind that grade 11 and matric geometry are worth the same amount in the final exam. Okay. Matric work. Okay.
I think the matric work has a, yeah.
Yeah, I think that seems to be. Okay, so if you want to go and practice this, there are lots of resources online that you can also use. All the NSC exams are on the department's website. You can go and have a look at those and practice. Certainly the beginning questions in geometry will all be grade 11 geometry. And then the matric questions will sort of come in a little bit later on. But you're going to see now when we go through this course how the two are going to be tied together. All right, so go and try and do what you can on your own as well, because it's just practice, 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 practice. Okay, matrics, well, all the very best. Thanks for all your participation tonight and your wonderful feedback. It's really awesome for Coco and I to be able to interact with you and help you. I hope you've enjoyed our lesson. And yeah, we'll see you again next week on Tuesday. All right, so take care and have a lovely weekend. Thanks, Matrix.
You too, ma'am.
Thanks,
Thank
Coco.
you,
Take
ma'am.
care. Pleasure.
Bye.
Thank you, ma'am.
Bye.
Thank you.
Thank you. Bye.
Bye, everyone.